Falcon 9 is not fully reusable vehicle, but Starship is. Elon Musk said that at Air Warfare Symposium on February 28th, described complexities to create the orbital rocket production line. And ironically, right after Elon's speech, just couple hours later, Starship SN1 prototype exploded during cryogenic test. Here is what Elon Musk said just couple hours before the explosion happened.
Well, Falcon 9 is a partially reusable vehicle, but not fully. The vehicle we're working on right now, which is quite difficult, is Starship. And that has the potential for full reusability. But I think it would be great to have other companies as well that are doing full reusability. I think competition is a good thing. It may seem at times that, shouldn't we focus all our efforts on one system and rather than divide them and have two competing systems. When trying different things, you've got to have some acceptance of failure. As you were alluding to earlier, failure must be an option. If failure is not an option, it's going to result in extremely conservative choices, and you may get something even worse than lack of innovation. Things may go backwards. If what you really want is you want reward and punishment to be proportionate to the actions that you seek. So if what you're seeking is innovation, then you should reward success in innovation, and only there should be minor consequences for trying and failing. There should be minor. With significant rewards for trying and succeeding, minor consequences for trying and not succeeding, and big and major negative consequences for not trying. Okay. So if you have that incentive structure, you will get innovation like you can't believe. But designing the production system of a new product is, I think, at least an order of magnitude or 2 orders of magnitude harder than designing the initial prototype. Less importance in modern times placed on manufacturing, and I think this is a mistake. At this point, I think designing a rocket is trivial, just trivial. There's like tons of books you read them, you can understand equations, you can design a rocket. It's real easy. If you say like two-stage, 2% of your liftoff mass to orbit, just to design something like that, piece of cake. Now, if you say you want to go into production with that, or if you want to actually make, let's say the next step is you want to make even one of those things. Okay, now making even one of those things and getting it to orbit is hard. But the designing of it is not hard. The making of even one is hard. The making of a production line that builds and launches many is extremely hard. And then the next level beyond that would be creating a fully reusable system and having that be in volume production and volume launch. That's super, super hard. I keep emphasizing to SpaceX, the hard part is making it and making lots of them and launching frequently. Because reuse must not just be, it can't be reuse like the shuttle. It's got to be rapid and complete reuse. So the shuttle was a case where the reuse was very slow and it was not complete. The main tank was lost every time, and refurbishing the shuttle between flights was extremely expensive. It's not even clear whether it was worth recovering the booster shells from the ocean. So just like an aircraft, the rocket must be rapidly and completely reusable, and then you need lots of them. What's needed to establish a self-sustaining city on Mars? These are like big numbers, but I think you need on the order of 1 million tons to the surface of Mars, useful payload. something like that. Because we sit on the top of a massive base of infrastructure, or the economy is. You think of all the things that are mined and then refined, and then just many steps in the refinement. And in order to produce like your phone or your toaster, even there's a vast base of industry that was required to produce even a simple household item.
Yeah.
It's very difficult. So you got to recreate that on Mars. And we're just talking orders of magnitude here. And hopefully it's not 10 million tons, and hopefully maybe it's less than 1 million tons, but probably not 100,000 tons. So that means you need to get about 5 million tons to Earth orbit of useful payload. Talking so essentially, unless you have a launch system that is somewhere in the megaton per year range to orbit, it's not relevant.
The SN1 prototype exploded like it made of foil. Technically, cryogenic fabrication capabilities allows to verify the work as well as other manufacturers. Starship SN1 stainless steel tanks are used for the test. Inside of the rocket there is helium leak detector with a sensitivity of 2 ppm. I think the rocket industry is currently going forward, and SpaceX as well as Blue Origin provide amazing service to push the boundaries. That was my quick review of Elon Musk's explanations on orbital rocket production line and technical risks of failure.